This question is very important for 3 marks question, that is expression for motional EMF. So what we are going to do, we said already, we have proved in the last class that by changing magnetic flux we can induce EMF. So now I am going to derive the expression for motional EMF, means by changing a conductor in the presence of magnetic field, how can we induce EMF? That is the concept behind this one. So to induce EMF, what we should do? We should change magnetic flux. For this, I have taken a conductor of this shape, okay, RS M L, and it is placed in a magnetic field. The length of this one is what? L. Now, I have taken a conductor okay, this is the magnetic field and this conductor name is PQ. What I have to do? To produce magnetic flux or to change magnetic flux, we should make a closed loop, right? We should make a closed loop. So I am bringing this conductor, means I am bringing this conductor toward this loop with some velocity. Now it comes to this point. For example, now this is PQ. It is coming with a velocity v. Now the distance of this one is what? X. So what happens now? PQRS is a closed loop or not? So for closed loop, what is the name of the closed loop? PQRS. What is the magnetic flux of this closed loop, ma? B bar dot A. So B, A, see, the magnetic field is perpendicular, the area of this is also perpendicular. So both are along same direction, angle is 0, cos 0. What is the area of this rectangle? Length into breadth. What is the length of this rectangle? L. What is the breadth of this rectangle? X. It keep on changing, but at present condition, at this time, it forms a loop of breadth x. So I can write as area is equals to BLX. So now the flux is changing because the conductor is moving in the presence of magnetic field and forms one closed loop. So we can use Faraday's law, right? According to Faraday's law of electromagnetic induction, what is that? E is equals to minus d phi b by dt. Is it right? Minus d by dt of phi b. What is phi b, ma? BLX. BLX. Here the magnetic field is uniform magnetic field, that is constant. The length of the conductor is not changing, minus d by dt of x. Because the value of x is only changing now. When you move conductor in the presence of magnetic field, what is changing? Value of x. So as we know that dx by dt is equals to velocity. Is it right? Rate of change of displacement is called what? Velocity. But it is moving against the direction of magnetic field. So dx by dt should be considered what? Minus v, because it is moving in opposite direction. So what I can write here? E is equals to minus BL into minus V. So what do you get? BLV. So the expression of for motional induced EMF is directly proportional to applied magnetic field, length of the conductor, and with what velocity it is coming. So motional EMF is what? Motional, the magnetic field, the EMF that is due to change of or due to relative velocity or due to change of its motion. That's why it is called what? Motional EMF. Clear? Next one. Next concept is what? Eddy currents. So very important for 2 marks. What are eddy currents is, for example, take water pool. In the water pool, throw a stone. What happens? It forms some circles around because you are causing some disturbance in the water by throwing a stone. So it forms some waves that will in the form of what? Circles like this. For example, if you throw a stone here, the waves will be spread throughout this water depend upon the stone you have thrown. In the same way, when a bulk conductor is placed in a changing magnetic field, means the magnetic field is changing. It induces currents in the form of eddies. Means the form of these are called what? Eddies. So that are called what? Eddy currents. So what you can say that? When a bulk conductor is placed in a, where we placed a changing magnetic field, the condition is what? Magnetic field will be changing, otherwise magnetic flux cannot change. It induces currents in the form of eddies. Called eddy currents. So let us know some applications of these eddy currents. What are the applications of eddy currents? Is they are used in induction furnaces, electric power meters, magnetic brakes in trains, and deadbeat galvanometer. So these are the applications of eddy currents. So this question is important for 2 marks. Clear?